Hi friends, welcome to webcam. In this video, I'm going to discuss what is variable and what are the best practices to use the variables in Power BI DAX. Okay, so variable is simply nothing but a named reference for any value, and that value can be returned by either expression, DAX expressions. That is also fine. You can store the values, even your own values if you want to store. Okay, but when while performing the calculations and where we use the DAX, so either we can use the DAX for the creating the measures, calculate the columns, and calculate the tables, even for the row level security. Okay, but yes, to simplify the complex calculations, we can use the variables. Okay, it is very similar. It looks like very similar to the measures, but little bit difference. Even measures are again one of the kind of variables. Let's see how we can create the variable. Okay, suppose you wanted to create the new measure. So I will go and I will create the variable. Okay, and let's give the name to the measure. Obviously, variables can be used while creating the measures and calculated column, or even calculated table. So I will say sum of cells. This is what my measure. And what I want is I wanted to, instead of performing the calculation and storing the value to the sum of cells, okay, meaning what I will do, I will be before using that value or assigning the value to the sum of cells, I will create the variable and I will declare var. Either you can use small var or capital var. Both are fine. I will say var. Okay, var, and I will use the variable called sum. Okay, this is what the name. This is keyword. That's why it is not allowed. Okay, but I will say total sales. Total sales, and is equal to, if I write the sum of, okay, sum of sales amount. Okay, and I'm going to do the same thing we can do with the help of measures also. But yes, measures are nothing but variables, kind of variables. Okay, if you are familiar with the other programming languages, it will be easy for you to understand what is mean by variable actually. So it is a name reference. What I'm doing, I'm declaring a variable and I'm assigning the one name, okay, total sales, to this, I mean to the value of this expression. Okay, that's why I said variables are named reference to the values, and this variable can be used any number of times during the your calculations. Okay, but in the same expression itself, meaning in the same measure itself. Okay, we cannot use the variables created in these measures into the another measures. Okay, that's not possible. You can use the measures, but you cannot use the variables. Okay, so return, and I will say total sales. Return total sales. So what this expression is going to do, okay, instead of assigning directly the calculation to this measure, what I did, I created one variable, and then I'm going to return the value of that value variable. Okay, so obviously this variable is going to return the, meaning going to hold the value of this sum of sales amount column expressions, meaning this expression output will be stored in this total value, and then I am returning that value. Okay, so by using return, whenever you use the variables, you need to return. Okay, but when to use the variable, that I will come to the point. Okay, the moment I hit enter, my expression will get, meaning the execution of this expression of this measures will get finished. Now what I can do, I can go and let me select this. Okay, and I will bring the value here. Okay, we are getting the same result. Okay, there is no, I mean nothing will change, nothing will happen. Even in case of measure, if you consider the measures are very similar to the variables. Variables in any programming language. Okay, like if you are familiar with the Python, Java, .NET, so then you will be able to relate this. What is measure? So measures are very similar to the variables. Okay, If I use another expression, that is what directly I created the measures. I assigned the sum of sales amount to the measures. Yes, that is also fine. So we can use the variable. Variables are not going to affect anything. It is not going to change the your calculation, but yes, it is going to help you to improve the performance of Power BI. Okay, how it is going to help, that I will discuss. Then it increase the readability, okay, and reduce the complexity of your DAX expressions. Okay, DAX expressions, fine. So if you go to the my data, okay, if you go to data, so there is a data for 2001 onwards until 2004. Okay, and what is my requirement is I may wants to find out. Let me write on the another report view. I may wants to find out. Okay, let's say percent change, percent change in sales versus percent change in sales of 2003 versus 2002. Okay, this is what my requirement. I have to calculate the change in percentage of sales by these 2 years, right? So what I can do, I can simply go and I can use this. I mean, I can simply, okay, fine. So let me remove this part also. Okay, so what we can do, we can use the measure. Obviously we are going to derive the single value, right? So we can use the measures. It is fine. It is good to use the measures. Okay, so what I will do, I will go and I can create the multiple measures, right? So I will create the, obviously, how to calculate the percent change. Obviously, percent changes versus previous year. If you want to calculate, what you can do, you can take the sum of previous year or current year minus previous year, divide by minus year minus previous year sum. Okay, so like this. So I'm going to create the sum of sales of 2003. Okay, this is what the, let's say this is what my current year. So how I can calculate, I can use the calculate function, and in this, okay, I can use the total sales measures I can use. But if you see, okay, if I try to, or if I wants to access the variables that I have created while this deriving this expression, okay, sum of sales, okay, total sales, if I wanted to use this, here, so I won't be able to use, but you can use the measures. Okay, so this is what the difference. Variables only available in the same expressions, but measures can be used in another expressions also, another measures also. Okay, so here I'm going to put the filter, and what I will do, I will say filter on the, okay, what is this? So filter on the year of, I'm going to use the year formula of date type, and year of, I will say order date. Okay, is equal to 2003. Sorry, not is equal to, it should be only equals to. This is what my filter. If I enter this, you will see that it has returned as the value, meaning yes, it is able to return, show me the value. I will remove this and I will bring this. Okay, this is the sum of sales for 2003. Same variable I am going, meaning same calculation, same measure I am going to create. So if I create the new measure, and if I paste the formula here, instead of this 2003, I will say this is 2002. Okay, fine. Now, this is the one way. Okay, here I will present the value of 2002. Okay, fine. So this is value, and I would like to find out the percentage change in sales. How we can find out, right? Obviously, what we can do is we can subtract the subtract the sum of cells of 2002 from this 2003, and then let's divide it by the 2003 cells. Okay, or either you can divide it by 2002. It's up to you what to consider and how to consider. Okay. So if I wanted to find out based on the 2002 sales, so I will use 2002 sales at a denominator. But how to use that? Okay. So for that purpose, what you need to do is you need to use, okay, you need to use this percent change. You need to use, or you need to create the another measure. Okay, it is fine, you are going to create the another measure, and here we have seen that we can use the measures, right? So what I will do, I will use sum of sales. Okay, it is not giving me the suggestion, that's why what I did, I simply used sum of sales of 2003 minus sum of sales of 2002. Fine. Okay, and I will surround this in a bracket. I will cover this in a bracket so that it will perform the calculation accordingly. Divide by, I will say, sum of sales of 2002. So if I consider 2002 sales as a base, so it will return me the percentage changes. Okay, and if I bring the value to the percent change here, so we can see that almost 50% sales is changed. Okay, 0.50. We have not multiplied any number with the 100 and all. So if you want to show this, but yes, not 0.50 percentage. Okay, since this is in a percentage, I need to multiply this with 100. So what I will do, I will use this so that it will show me the exact number or what exactly it should. Okay, so 49.93%. So this number, but here to calculate this, okay, what you did, you used three measures, right? Three measures. So this can be avoidable using the variables. Okay, let's see how. But before that, okay, there is one more way. Even you can calculate the all these percentage. Okay, percentage. Let me before going to that, let me copy the one of the formula. Okay, this is what my formula. So in single measure, even you are able to do that also. So let's see, we will get the same result in this way. I will say percentage change in sales. Okay, and what you can do is, okay, let's say this is your formula. I'm doing the same thing. Okay, but here what I will do, I will change the year. 2002 sum of sales minus 2002 divide by, if I use the 2002 sales. Okay, this calculation even gives me the same result. Okay, and what I will do, I am going to multiply this with 100. Okay, but before multiplying, I need to surround this. Okay, so this looks little bit complicated, right? Even though this is very easy, you can split, you can create the multiple measures and you can compound them into the new measure. That in that way also you can go and you can create, even in this way, the way I used now, in this way also we can perform the calculation. So it is fine. Okay, it is able to perform. So let's see, you can see that both the formulas give me the same result. Nothing changed. The same thing I did. Instead of creating multiple variables, what I did, I used the single measures to use. But here, what is the problem? Okay, if you have to calculate the sum of sales for 2003 year twice, then this increase. Okay, sorry, sum of sales for year 2002 twice. Okay, in the numerator also, in denominator also. So this increase the load. Okay, this definitely takes the time. Okay, obviously this increase the loads on Power BI. Even readability of this DAX is very, meaning this measure code is very complex. So to simplify the readability, okay, so variables are going to help us. The same result, okay, you can do, but you can avoid even multiple times the same calculation. See, if you use the calculate functions, so it is going to going to perform the calculation for that instance. But I don't want to do that. Okay, if I need the same value for multiple times in my expression, so I can use the variable. Okay, what I will do, I will use this, and here I will create the variable. Instead of doing this, what I will do, I will say variable var. Okay, var, and sales, I will say 2003. Okay, so this is what the variable name. Don't put the space and all for the variable. And this is what my calculation. Okay, so I'm storing the value, right? Yes, I'm able to store the value that I discussed even just before, sometime before. So I will say sales 2002. Okay, and then here. So instead of performing the 3 times calculations like I did earlier, what I did now, I performed 2 calculations only, and I store the value, and even this value can be used further. Okay, let's see how. Okay, if you want to subtract, okay, so you can say sales difference is equal to, even you can create another variable, that is also fine. You are going to perform the subtraction here. So you can use the variables 2003 minus 2002. Okay, in this way. Now this returns the subtracted amount. Now what I want is, I wanted to find out the percentage. Okay, I will say return. And there is a function called divide. You can use that function also. It is fine. Otherwise, you can surround and use the denominator operator. Okay, sorry, division operator. So let's say numerator. What is my numerator? So numerator is my sales difference. Okay, so here you can see that variables. If you look at the variables, okay, so these are represented by the X symbol. Okay, X symbol. So if I go and if I say sales, so there is X in before the variables. Okay, so you can use sales difference and then divide by, okay, again I will say sales of 2002. If you want to use the 2003 sales, you can use, and this is what I'm going to return. Okay, so now this reading of these expressions is very easy, meaning this improves the readability, and even this has improved the performance. Why? Because same calculation is not happening couple of times. If you are going to use the same number multiple times in your expression, so it is always better to create the variables and use that for your calculation. I will hit the enter button. You will see that it returns me the same result. Okay, since I have not multiplied that with the 100, that's why. Okay, but yes, what I will do, I will say 100. I will multiply this. This is fine. Okay, and yes, it is able to return me the same result, right? So this is how we can use the variables, and this is how variables are going to help us to improve the performance. Even it improve the readability, and that's what we did here. Okay, in this way also you can perform. So instead of creating new variables to take the sum, so we can use. Okay, it's up to you. What variable name can be anything, but don't include the space and all, like we add the space in major names. It is not support. Then what is difference between measures and variables? Okay, let's understand. Okay, so measure cannot refer to the variable defined in another. Okay, meaning you cannot use variables, cannot be used into another measure. Okay, another measure. Okay, meaning if you create the variable while creating the one of the measure, okay, while creating the one of the measure, like here I used here I used variable. So sales underscore 2003 will be available for this expression only, meaning in this measure I can use that variable. I cannot go and use this 2000 sales underscore 2002 variable in the sum of sales, okay, in the another measure. Not possible. Okay, even if I try to say, okay, here, no, it is not possible to use that. Okay, but yes, so measures instead of variables, measures can be used, right? So let me say measures can be used into another measure. So this is what the difference actually. So we can say, okay, in programming way, we can say that this is a global variable, okay, and global variable, and this is local variable. Local variable. For the understanding purpose, I defined global variable and local variable in this way. So variables in DAX are always a local. It will be available in the same expression only. It cannot be accessed outside of the define, meaning outside of the expressions where it has defined. Okay. So variables can refer to the measures. Variables can use the measures, but measures cannot use the variables. Okay, that is fine. So this is what the major difference between variable and measures. Right. So both are the kinds of variables you can refer, but slightly difference is that measures, one measure can be used into the another measures, but one variable cannot be used into the another measures. So this is what the actually difference, and I hope you like the content of this video. Thank you so much for watching the video. Have a nice day.